Why, hello there again. Today we're talking about taking derivatives of trig functions. Okay, so we start with basically the sine and the cosine function that we need to know how to derive. The derivative of cosine, so if we're calling g cosine, then g prime of x is going to be the negative sine. Okay, cosine has a derivative of negative sine. And over here, the sine has a derivative of cosine. Okay, so these ones you're just going to have to memorize, right? These derivatives. Sine becomes cosine when you take the derivative, and cosine becomes the negative of sine. Okay? Now we're going to use that fact to find the derivative of all these other ones. Okay? So secant, we're going to find dy dx, or d secant dx. Okay, we're going to find the derivative of secant. So we're going to first write this as 1 over the cosine, right? This is the same function. Secant is the same as 1 over the cosine. So what I have now is a fraction. In other words, I'm going to use the quotient rule to take this derivative. Okay, so that is the low term times the derivative of the high, so the derivative of a constant is 0, minus the high term, which is 1, times the derivative of the bottom. Now remember, the derivative of cosine is negative sine. So negative 1 times negative sine divided by the cosine squared. Maybe I'll write it like this. Maybe I'll write it as cosine squared like this. Okay, so derivative of the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator times the denominator squared. Okay, so let's see what we can do to simplify this. I know negative 1 times a negative sign is actually a positive sign. And cosine squared I know is, well, cosine squared. So I can take that squared and write it in here. Okay, so we're going to invite some trig substitution real quick, and I'm going to break this fraction into the product of two other fractions. Okay, so this is what we do sometimes in calculus and in pre-cal, is we can split this single fraction here, right, where a sine over cosine squared, into the product of two fractions. So the sine over the cosine times 1 over the cosine, right? If I multiply these together, I get cosine squared and over under sine. So now I'm going to do some more trig substitution. Okay, the cosine of x over the sine over cosine, that's also known as the tangent, and 1 over the cosine is known as the secant. So if I'm taking the derivative of secant, the answer comes out to be tangent times secant. Okay, using that quotient rule. A very interesting derivative, something that you can memorize, or you can always just derive it by using the quotient rule. So let's see what happens when I do the same kind of thing with cosecant. Remember, cosecant is also known as 1 over the sine. Okay, 1 over sine. Now when I take the derivative, right, when I take the derivative, let me change colors. When I take the derivative of this with respect to x, okay, I'm going to once again use the chain rule. Sorry, not chain rule, I'm going to use the quotient rule. So I take the low term times the derivative of the numerator minus the numerator times the derivative of the denominator, right? So derivative of sine is cosine divided by the denominator squared. Okay, low times the derivative of the high thing minus the high times the derivative of the low over the low thing squared. Okay, and a similar type of problem is what we can end up with, right? We have negative cosine over sine squared, which once again I'm going to break into, right, the negative of cosine over sine times 1 over sine. Okay, because when I do this, now I have some trigs that I can substitute. So cosine over sine is known as the cotan. So negative cotan, since it's a negative function there, and then 1 over the sine is once again the cosecant. And of course, these can be interchanged. It can be negative cosecant times cotan, or it can be negative cotan times cosecant. Both of those are equivalent. So the derivative of cosecant is negative cotan cosecant, and the derivative of secant is tangent times the secant. Okay, kind of interesting. So let's see what happens when we use this idea to take the derivative of tan, which tangent is the sine over the cosine. Okay, so when we take the derivative of that with respect to x, I'm once again using the quotient rule. So denominator times the derivative of the numerator, which is cosine, right? Derivative of sine is cosine, minus that numerator again, which is sine, times the derivative of the denominator. So derivative of cosine, once again, is negative sine. Okay, sorry, the minus kind of slipped in there, but negative sine over the denominator squared, which is cosine squared. Okay, so we're going to do some simplification. Right, cosine times cosine is cosine squared. Negative times a negative is a plus sine squared, all over cosine squared. Now, if you remember your trigonometry, this is a Pythagorean identity, cosine squared plus sine squared. So I can replace that with just the number 1, because cosine squared plus sine squared is always equal to 1. So 1 over the cosine squared becomes the secant squared. So the derivative of tan is secant squared. Okay, by using this quotient rule. And I guess we can maybe be able to guess what cotan derivative is. Okay, if the tangent became the secant, I'm betting the cotangent is going to become the cosecant squared. But let's just go ahead and verify that. So cotangent is known as the cosine over the sine. Okay, so we're going to take the derivative with respect to x of cosine over sine, which is the low term times the derivative of the high. Okay, so sine times negative sine, derivative of cosine is once again negative sine, minus the top term cosine times the derivative of the denominator, which is cosine, all divided by sine squared, or sine squared. Let's write it like this, sine squared. Okay, so some simplifying, sine times negative is negative sine squared, minus the cosine squared, all divided by sine squared again. So notice that I have 2 negatives in my numerator, so I'm going to factor out 1 negative. Well, factor out a negative from both of them, because now I get my Pythagorean identity again, sine squared plus cosine squared. Okay, so I'm going to replace that once again with 1. Right, all of this right here is 1. But I still have my negative out front, so the negative stays, and it can go to the whole entire fraction. It doesn't have to stick with the negative 1. But in essence, I have negative 1 over sine squared, which is the negative of cosecant squared. Okay, so my guess was not correct, right? I guessed that it would be cosecant, but it turns out that the derivative of cotan is negative cosecant squared. Okay, now you can always derive any one of these, but memorizing them might make your other world of trig and taking derivatives a little bit faster.